Find rational zeros.
For more videos, don't forget to subscribe. Formula. Possible rational zero is equal to the factors of the constant term over the factors of the leading term. Example equation. The given equation is f of x is equal to x cubed plus 2x squared minus 11x minus 12.
The leading term is x cubed, which has a value 1.
The constant term is 12. Example number 1.
Find the rational zeros of p of x is equal to x squared plus 5x minus 6.
On the given equation, the constant term is -6 and the leading term is 1. Using the formula, the possible rational zeros is equal to factors of the constant term, or p, over the factors of the leading term, or q. The possible factors of -6 are negative and positive 1, negative and positive 2, negative and positive 3, and negative and positive 4, and for factor 1 are negative and positive 1. Let's expand the ratio of constant term and leading term. The expansion are the following.
The quotient of the factors with a denominator of 1 are 1, -1, 2, -2, 3, -3, 6, and -6.
The quotient of the factors with a denominator of -1 are -1, 1, -2, 2, -3, 3, -6, and 6. Simply, the possible zeros or p over q are 1, -1, 2, -2, 3, -3, 6, and -6. Apply the remainder theorem. Through remainder theorem, we can determine the zeros of the given equation if the remainder is 0. From the table shown in the first column of table are all the possible zero that we have done in the previous slide. Through substituting in the equation, by changing the value of x, it shows that the 1 and -6 provide a zero remainder, therefore, they are the zeros of the equation, x squared plus 5x minus 6.
Take note. Another method to check the zeros is by using synthetic division.
Example 2. Find the rational zeros of f of x is equal to x cubed minus x squared minus 3x plus 3. First identify the constant of the given equation.
Constant term of the equation is 3, and the leading term 1.
Next is use the formula. The possible rational zero is equal to factors of constant term, or p, over the factors of the leading term, or q. The possible factors of the constant term are positive and -1, positive and -3, and for the possible factors of 1 are positive and -1. Here are the expanded form of the possible zeros. The possible zeros, 1, -1, 3, and -3. Another possible zeros are -1, 1, -3, and +3. Simply, the p over q, or the possible zeros are 1, -1, +3, and -3. Use the remainder theorem to identify the zeros of the equation. Remember, the equation is cubic, therefore, there are 3 possible zeros. You can also use synthetic division to identify the zeros if you want, but in this table it uses the remainder theorem. Now, as you see on table, only 1 give a remainder 0, therefore, 1 is a zeros of the given equation. Now we need 2 more zeros. Now we will use synthetic division to find the other. We will perform the synthetic division. Get all the coefficient of the given equation, x cubed minus x squared minus 3x plus 3. Then get 1, which is identify zeros that will serve as the divisor of the division. The quotient is 1, 0, negative 3. Then transform it into polynomial or algebraic expression. The expression is x square minus 3. Equate the expression into 0, then, the equation is x square minus 3 is equal to 0. Perform the additive inverse, then, the equation become x square is equal to 3. Then extracting square root, both sides of the equation. Then, the values of x is positive and negative 3. Thus, the zeros of the equation x cubed minus x square minus 3x plus 3 are 1, negative square root of 3, and positive square root of 3.
Example number 3. Find the rational zeros of f of x is equal to x to the 4th power plus 9x cubed plus 15x square plus 11x plus 3. First, identify the leading term and the constant term. The constant term of the given equation is 3, and the leading term is 2. Use the formula of possible rational zero. The possible factors of 3 are positive and negative 1, positive and negative 3. The possible factor of 2 are positive and negative 1, positive and negative 2. Here are the expanded form of possible ratios. Here are the simplified form. Simply the P over Q, or the possible zeros are 1, negative 1, 3, negative 3, 1/2, negative 1/2, 3 over 2, and negative 3 over 2. Apply or use the remainder theorem. The table shows that negative 1 and negative 3 over 2 gives a remainder which is 0. Therefore, they are the zero of the equation.
The given equation is 2x to the 4th power plus 9x cubed plus 15x square plus 11x plus 3, then, get its all coefficient. Take note the equation is in 4th degree, therefore there are 4 zeros of the equation. We already find the 2 zeros, which is negative 1 and negative 3 over 2. Now, use the negative 1 as the divisor on the first synthetic division.
The result of the synthetic using the negative 1 as a divisor is 2x cubed plus 7x squared plus 8x plus 3. Perform again the synthetic division in this equation, and use the next identified zero, which negative 3 over 2 as a divisor. The last quotient is 2 squared plus 4x plus 2. We can simplify the equation by dividing the expression by 2. The simplified form of the expression is x squared plus 2x plus 1. Now we factor the equation into x plus 1 multiply x plus 1. Apply the zero product property in each factor. Then the value of x is negative 1 and also other is negative 1. Therefore, zeros of the equation are negative 1, negative 1, negative 1, and negative 3 over 2.